So first of all, thank you for taking the time to listen to me. I'm here to present you guys ZML and our first product, which is LLMD, our fully homegrown LLM server. So before I get to the demo, maybe a quick intro about what we do. We are building a chip-agnostic inference stack, right? So why did we go that route? Well, starting with the story of on one side it was training, on the other there was inference, and these two obey very, very different, I would say, tectonic forces. Training is more like a research, one of something. More is better. You might want to have actually privilege fast iteration, and for that Python is a very good fit, right? But for inference, actually it's pod, right? So we are not making one of something, we're building billions of something. So we run the models, let's say, billions of times. So in these environments, less is better, and we want predictable latency, and for that Python is okay. So the question is, why do we need another framework, right? Well, the thing is, at least so far in machine learning, training won. So everything you would do in pod would be essentially sort of bending, training code to do inference up to a point. So mind you, I like Python. I used to run it a lot. It's a great language. It's very easy to use. And oh, what's that? Oh shit. Okay. All right. Yeah, I see a lot of people share that pain, and I have the scars to prove it. So really quick, who are we? We are AI-flavored backend engineers, right? So we're the ones who operate these systems. We're the ones who put them in production. We're the ones who wake up at night. And so what do we want? Well, the number one thing we want is accelerator agnosticity, right? We want to be able to run on whatever best chip du jour or whatever chip we have or we plan to buy. Maybe today, but also tomorrow. So agnosticity today means heterogeneity tomorrow. But also we want very high performance. So we want compiling, we want static typing, cross-compiling, sandboxing, all of these things included. And for that, this is why we built ZML. So I will spare you the rest of these slides and let's go straight to the demo. So you're all in luck. This is the first time I'm demoing our, much better. Can you guys see it? No. Okay, I'll zoom in. So I'll do it remotely. There we go. So it will be a very simple demo. This is the first time I'm showing it publicly. So super happy to be here. We're going to run LLMD or homegrown. Oh, bigger. All right, there we go. Actually, you know what? Let's do it like this. So it's an LLM server, right? So we'll answer, it's going to run a Llama. So let's start it. This one runs on, let me kill this. This one runs on H200. So it's a full-blown cold start. It should take about 20 seconds. And it should be listening in a few. All right, there we go. It's live. So pretty fast, if I do say so myself. Let me just do the. All right, let me do a tunnel real quick. And it is indeed. So this is a sample app that talks OpenAI, right? So the first launch is a bit slower, but then yeah, it answers, and then it's an LLM server, right? So. There we go. Super cool. And it will answer, right? So now that was step one. So of course it runs on NVIDIA. We can talk about performance later, right? But it runs on NVIDIA, fairly simple so far, right? So now let's up the ante a bit and let's run it on AMD. All right, so that will be very interesting from here. MI300. So this is a machine with a 8 MI300. Let's go on our monorepo. Of course, I need to copy my Hugging Face token. Hugging Face. Else it will not be happy. It's fine, I'll change it. It's my gift. So this is now running on MI300. Actually, come again?
What model is it?
It's a Llama 3.18B. Let me actually do the tunnel here. So it's a slightly slower to start on MI300. Mind you, I didn't change anything, right? I just run it. It's one of our promise is that you shouldn't, have the model code be aware of the accelerator. You just run your stuff. Oh yeah, so it's listening now. So let's go, and if I did as expected, it should answer. First launch is a bit slow. Yeah, there we go. So let's do it again. So yeah, now it's an LLM solver, right? So, but the important part is I didn't touch, like on the Llama code, there's nothing specific to MI300. There's nothing specific to NVIDIA and whatnot, right? So far, we support 4 architectures. NVIDIA, of course, AMD, Google TPU, and Amazon Trainium. The only thing you need to do, so let me actually kill it real quick. The only thing I did is to say that I want it to run on ROCm. That's it. If I go on the NVIDIA one, the only difference is that I replaced ROCm with CUDA. As a matter of fact, both machines don't have either CUDA or ROCm installed. Only the driver. This is one of the things, I would say one of the things we do that a bit special is that we sandbox the runtimes as well. Less work, more reliability. And last but not least, performance. It's pretty good. I will not, talk about it on video yet because I don't want to get, lasered up from the sky, from orbit. But no, we're very happy with performance. One of the reasons is that we use Zig as the programming language. And so let's just say there's not much time we spend on the CPU because, between tokens, let's say, in Python, even though, a lot of it happens in the GPU, there's still overhead, You still have to serve connection, you still have to JSON, you still have to tokenize, you still have to do all these things, which is a very good advantage for us because we can do that at very, very high speed. So I would say the latency between kernels is very low, microseconds, right? So very happy about this. And that's it. Thank you. Thank you very much.